Okay, so we just looked at how to make a parabola shift up and down. And remember, to make something shift up and down, it goes on the outside of the x squared item. And it does exactly what it says it's going to do. So if it says plus 3, it moves up 3 spaces. If it says minus 6, it moves down 6 spaces. Now the next thing you're going to probably end up doing is making objects shift right and left. And to get objects to shift right and left, that's obviously a horizontal change. You have to look inside of the function. So the inside of the function is going to be inside where the squared item is. Now, the horizontal shifting, it always lies to you. It lies every time. So if you see a plus a number, normally you would think plus 2 is positive. Move it to the positive right direction. And it's lying to you. If you see a plus a number, it's actually moving your object to the left. And if you see a minus a number, it actually moves your object to the right. The vertical shifts, which are on the outside, they do not lie to you. So they always tell the truth. So if you see plus, you move up. If you see minus, you move down. Okay? So for example, remember that your parent function is y equals x squared. If you start to notice that you have some parentheses introduced, and inside those parentheses, they start taking numbers and adding and subtracting them, that's going to make your object shift right and left. So for example, if you see minus 3, remember that if it's on the inside, it's a horizontal shift, and that it is lying to you. So if you see minus 3, normally your brain's going to think, oh, minus, go left. Wrong. It does the opposite of what you think, and it's going to actually take your object and shift it right 3 spaces. Okay? So just to prove the point, I'm going to show you a t-table. And I always like to pick the number 0 because usually on the parent function, usually your object is centered at 0, 0. But keep in mind, I just told you that your object was going to get shifted 3 spaces to the right. So if that's true, that means your vertex should really be happening at the dot 3, 0. So let's see if that's true. So I'm going to put 3, 0 right in the middle. And I'm going to pick a couple of points that are on the right side of 3. And I'm going to pick a couple of points that are on the left side of 3. So notice your 3 is your vertex, and it should be right in the middle. Okay, so let's see if it works. If I substitute 3 in for my x, do I get 0? I sure do. Okay, so let's try, let's try the number 1 and substitute it in and see what happens. If I substitute the number 1 in for my x, 1 minus 3 is a negative 2. Negative 2 times negative 2 should give me 4. All right? Now remember, if 1 gave you a 4, the 5 is equally spaced away from the vertex. It should also give you a 4. Let's see if that's true. If I were to put 5 in there instead of 1, 5 minus 3 is a positive 2, and a positive 2 times a positive 2 is also 4. All right, that's good. Let's try our 2. Let's see what happens when we substitute 2 in there. Sorry, I'm trying to erase. It's not working. Okay, let's substitute 2 into the function and let's see what happens. So if I was to put 2 in for my x, 2 minus 3 is negative 1, and a negative 1 times a negative 1 is a positive 1. All right, cool. Now let's see what happens if I plug the positive 4 in there. If everything is working as we think it should, the answer you get when you plug in the 2 and the answer you get when you plug in the 4 should be the same answer, but let's double check. So if I was to plug the 4 in where the 2 was, 4 minus 3 is a positive 1, and a positive 1 times a positive 1 is a 1. All right, let's check out the graph, and let's see if indeed, when I saw a minus 3 on the inside of the function, let's see if it actually moved it to the right. Okay, so I'm going to get myself a little graph here. Just going to move this up a little bit so I can graph it. Get myself a little a little XY coordinate plane, and I'm going to plot my point 3, 0. I'm going to plot my point 4, 1. I'm going to plot my point 5, 4. There's the right-hand side. I'm going to plot my point 2, 1. I'm going to plot my point 1, 4. And there's my left-hand side. Does it appear that they just took your original graph and moved it 1, 2, 3 spaces to the right? They indeed did, and you can tell that when it's on the inside. That's going to be a horizontal shift.